G'day. A little bit more on the Taylor Hobson rotary whatchamacallit today. I guess the big thing is that I've put the thread on here, reduced that down for the clampy bit, and put the graduations around. And putting the graduations on there is something that I think it'll be interesting to most people, because whether it's a round scale like this or it's a linear scale or something like that, the basic idea is the same. And so I show you the tool that I've made up to do that. To start, this is the table from the Taylor Hobson rotary fixture, and I've taken that down to 1.5 inches because there's a clamp piece that goes onto that, and I've also put an M50 by 1 thread on here. The original is a 2" by 26 or something like that, I think, but I thought I'd do metric. So I've put that on there. I used the thread mic to get that to about the right size. I now need to make up the nut for it. The other thing I have to do, for some inexplicable reason, must have had a brain fade or something, I've left this bit here 17mm too short. So what I've done, I've put a 45-degree chamfer on there. I'm going to put a hole in there which is just going to act as a pilot, and then I'll need to make up a little bit of a stub, push that in, clamp it, weld around, machine that back, and fingers crossed, no one except you, me and the rest of the internet will ever know any different. This whole thing is going to be drilled out when I'm finally finished anyway, because there's occasionally, you want something to go through there. But for the moment, a small spigot in there will get drilled out anyway. You won't notice it, but then I have a seam around there, and I can machine that back concentric with the rest of the assembly. This is the piece of material for the nut that I need to make onto that spindle now. I want to face that off. That's just an old saw cut. But the problem I have is that tool there won't actually fit. If I try putting that in there, the gap there will mean that this will, once that tip is in contact, this is going to smash the jaws. It is for a nut. I could pop a hole through there and then use something like a boring bar, or a tool like this reversed and face across there. But sitting in my box of rarely used things, I've got this thing. This is a boring bar, but it's in the reverse direction, and that when I present it is just small enough that I can get in there on this chuck and do a skim there. I only want to take off 0.2, 0.3 of a millimetre, but this will just do it. And whenever you're setting something like this up, do rotate things around just to check that you don't get something hitting. But when you see tools like this, particularly second hand, because no one knows how to use them or knows what to use them for, something like this does come in handy. Once every couple of years I have a job like this where I need to do something where a normal tool won't reach, so it's a handy one to have. That was a bit of an anticlimax, really. I turned up my nut blank. I've got it in 3-jaw here. I'm right at the limit, and the reason I'm using a 3-jaw and not a 4-jaw is that I wanted to get this thing with a bit of clearance behind it, and the 4-jaws with the jaws reversed wouldn't give me that, and the one I do have with the jaws the right way around hasn't got much clearance between the back of the part, or wouldn't have much clearance between the back of the part and the chuck. So anyway, set that up, ran a couple of passes, and then tried it for size on the spindle, because I knew I'd taken this out probably a little bit more than it should be, and it fits beautifully. So next step, put a slit in there, and that will hopefully close up a little bit like the original, but if not, I can just give it a bit of a light squeeze. And then I need to do the extension piece for this, and then pretty much up to graduation. Here's my repair. So to do this sort of thing, first of all, you try not to do it in the first place, but sometimes you can't help it. And this was done some time ago, so I may have been thinking something completely different at the time. So I put a bevel on this part at the end. I put a small hole in there, about diameter 10, but only 3 or 4 millimeters deep, just to provide a location. I made up a plug with a little matching spigot on there and pressed that in, and then I welded around with the TIG torch. This piece was slightly oversized. This is 1.5 inches, and this one was 1.53, I think, 4, something like that. So slightly oversized, but enough that I could still get decent penetration with the weld there. I then came along and very carefully centered this up in the fore jaw using that surface, and got that to within probably 3 to 5 tenths, something like that. And then very carefully machined this down to size. It's within probably half a thou, I think, of that diameter to that diameter. I didn't want to go too small because I didn't want to get this diameter down a little bit. And then I've given it a bit of a polish, parted it off to the correct length, and then put a centre in there because I'm going to come back and drill that, so I might as well have a centre to help me with that. It means I can then strap this to the milling table really and use and do it that way rather than having to come back to the lathe. But you know, that's a repair when you haven't got enough material or whatever the story is, and it seems to work all right. There's going to be a clamp over that, so you won't see that slight witness line there from the weld undercut. I did do a couple of passes to make sure I had lots of material there, but it looks like I've just undercut on one side there. Doesn't matter. As I said, there'll be a clamp over the top of that. So yes, that's the repair. So now that I've got that done, I can take this over to the graduating machine. This is my line graduating device, and it looks like it does because it's one of those things that I made for one job that I had, and then just sort of popped it in a corner and forgot all about it, and then another job came up and I thought I should really paint that thing or something, and so on and so on. And so I've used it probably a dozen or so times, and each time I use it I think that'll be the last time. But that's the way it goes sometimes with these things. So in simplest form, a couple of brass bushes and a bit of rod that just slides back and forth. There's a lever here. It does have a slot in it, for those of you worrying about the geometry. So I have a bolt that just sits in there. It's not a terribly tight fit or anything like that, but that just gives me the ability to go back and forth. I use a bit of broken tap as a scriber. No one else on YouTube breaks taps, but I do, and so this one was a 5/32 once upon a time. Oh, this is a milling cutter, yeah, 5/32 milling cutter. But that'll go in there, and then there's a grub screw that'll come in and do it. Now, to adjust the length, I've got these, and I must have taken some care once upon a time because I put in I've actually labelled these things. So I just got different strips of metal, and I put them in there, and that provides a stop. And so by doing that, if I want line say 5 millimeters long, and then 7, and then 10, I can do all that sort of stuff, work out where things go, and set it all up. I've made up a little plate which bolts onto the face plate. I'll come in onto that with the fore jaw, and that'll give me plenty of clearance there. So I'll get that all set up. This is why I don't do this often, because it does take some time to get everything dialed in. So I've got my blank so that it's rotating true to the spindle of the rotary table. I've got my scriber. It's jacked up on around about 35 millimeters worth of packer, and the reason for that is that when I made this, I had a smaller dividing head, and so it worked quite nicely there. This one I've got to jack it up, and what I probably should do is put something under there to space it up, but as I said, I'll never use this again. So, That's sometimes the way it goes. I've got my stroke sorted out so that when it's right back, it just clears the table. You can see on the piece of tape that I've got 3 lines, so the lowest one there is my units, the next one up is the 5s, and the next one up is the 10s. And they'll do. There was another one of the spaces I had was even shorter. If I wanted to have some weird sort of geometric progression between the marks, I could make up new spaces because they're only a bit of flat. What I'm going to do now is set the table up so that I do 72 divisions, and I'm going to alternate between my long and my second longest, and I'm going to put them in place, because if you lose count, you've just ruined your job. So if I put the long ones in first and then I go around and index round to put all the units on, the unit should overlay the longer ones anyway, so it won't matter if I miscount. So first lot is the 5s and the 10s, and then I'll go back and do the units. This is the first go round, so I've put in my 10s and my 5s. There's just a little bit of a burr. As you can see, they knock off pretty easily there. I'm now going to put the stopper in to do the ones in between, adjust the dividing head, and that'll be this graduated. I then just need to put some, I guess, some numbers on the top there. Have to work out how to do that, whether I use the engraver or whether I just use metal stamping. It's probably 6 one, half dozen the other, but that's the engraving process. Finally done after all 365 graduations. I've also just run over with a file just to knock the burrs off. Numbers will come later, and I've got an infilling crayon which I'll use to sort of darken those up. But basically, there's the degree scale. Depth, by the way, was just done by pushing the stylus in a little bit. If you wanted something really deep, I guess you could go around and do it again, but this will be fine for what I do. And I guess the other thing about having a deep mark is just that it becomes broader and you lose a little bit of precision. Anyway, that's the graduation process. So thanks for watching, and we'll see you for the next instalment.